I'm now inviting the Academy member, Professor Meir Lahav, to share with us his greetings to his good old friend, Professor Leiserowitz.
Thank you, Hanna. Thank you, David. Very glad to be here. I must tell you that this is my first experience, first time that I have to present similar story that I'm doing today. When Leslie retired 25 years ago, I have to organize this meeting, and I also have to greet him. When he was 80, I did the same thing. I organized a meeting for him, and I greeted him. Last April, we had a meeting at the Weizmann Institute, 90 years. And I did it. And I greet him again. And when I was asking myself, what I'm going to say today? After what I'm going to say today that I have not said in my previous cases. And then it occurred to me, because Leslie's work, has done so many things in work, So I decided to focus on one particular point. About 2 points, 2 problems, and 2 of it that Leslie has elaborated on them, that he got the inspiration, as David pointed out in his talk, we didn't coordinate it out between us, that he was very deeply inspired by his mother and by his father. His mother had a special thing to that, patterns for dressing. And Leslie was very, very much impressed by these patterns that he used to see every day. And then one day, he had the opportunity to read the book of Bragg and Bragg. He was not a crystallographer. He started his work in actually electric engineer. He was unemployed. And since he was unemployed, he decided to read books. And one of these books by Bragg and Bragg, he noticed these beautiful patterns in the crystals, which remind him from the patterns that he saw in his mother dressing. And he always used to say that. And therefore, he decided to go into crystallography in order to understand these beautiful patterns in crystals. The other effect, which was very important, was from his father. His father used to work in Central Africa, and he came across about the diseases, the suffering of the people from malaria. And he always used to tell stories to Les about malaria. And it so happened that Leslie could really, at the end of his, actually after his retirement, to understand and to come across that malaria is also a disease that has crystallization. And he was very, very excited to work on that problem. I remember the early days when he started working on this. He was so excited. I can really bring problem stories that I've heard from my father. I can do something for humanity. So after that, at the age, actually 1959, Leslie decided to move to crystallography. He contacted Gerhard Schmidt at the Weizmann Institute, and he came to the PhD thesis in the Weizmann Institute, working on thermochromy and photochromy. But after he completed his thesis, the first thing to do is to go to understand the packing and the motif of molecules in crystals. What he calls molecular packing modes, right? And that time, crystallography was a very, very bizarre, I think, very difficult, artistic science, I would say, because you start measuring a crystal, but you were not sure whether at the end of that you're going to get the crystal structure, that because there were not analytical tools that could really solve the crystal structure of a simple molecule. But most crystallographers in the world used to work on trying to develop analytical tools in order to solve the crystal structures. But Leslie was actually interested in the motif, how molecules in crystals are organized. Maybe I see the first slide. Well, in order to give you the state, what was the situation, the state of the field of crystallography at the time. And the editor of Nature, Meadows, actually wrote an editorial article in Nature and saying one of the continuing scandals in the physical sciences that it remains in general impossible to predict the structure of even the simplest crystalline solid from a knowledge of their chemical composition. And the problem with that was how you can determine the crystal structure of a compound, of a sample molecule. It was impossible. And what Leslie was trying to do is trying to understand how molecules which have certain functional groups forming some kind of hydrogen bonds, what will be the pattern of such molecules in a way to be able to understand the packing modes of such molecules. And this was very, very important, because at that moment, actually, our collaboration started, because we, on the other end, were much more interested in crystal engineering. Because the problem was, at that time, was the point how you can predict a target that you would like to perform and to build up a crystal that might have a specific functionality. And using the rules of thumb that Leslie was getting from his pattern understanding, it was possible actually to try to predict crystals and to perform to create some new crystals and with new predicted functionalities. And the second point was the problem of malaria. The story started like that some of the work and the studies that were performed at that time were near surfaces. And it was very, very important to elaborate crystallographical techniques that you can determine the structure of some self-assembled structures, nanoparticles, which might serve as nucleation centers for the creation of the crystals. I mean, how crystals are formed. They start from the solvent. The solvent self-assemble into certain patterns, and this nuclei can serve as nuclei to form the crystal. And then there were no techniques to assign the structure of molecules at the interface, in particular the air-liquid interface, because at the air-liquid interface you can create such intermediates which could be efficient models for starting the understanding of crystal nucleation. And then it happened that Professor Jens Als Nielsen, that was supposed to be here, and one of the pioneers in the physics of X-ray scattering from surfaces, actually met Leslie, and Leslie, together with Jens, elaborated a new crystallographical method to analyze the structure of self-assembled nanoparticles at the air-water interface. And this information of the science that could occur near such surfaces, such liquid surfaces, was very important, not only for understanding the early stages of crystallization, but also had a very important biological importance, because many of the membranes, which were, let's say, membranes and all kind of chemical and physical that occur near membranes could be really analyzed on the molecular level. And I remember the first example, and then I see Sharon is shining, because Sharon was the first that performed the first experiment in this, and the paper was published in Nature to try to find the first asymmetric, let's say, nanocrystal on the molecular level. And this, of course, continued further. Jarek, which is their problem, did a lot of work, and Hanna started to do some experiments with cholesterol. And this allowed Leslie now to move in the field of what he calls structural biology, investigating cholesterol, how it organized in the vessels. And of course, he understood and he noticed that also malaria is another disease which has a problem of crystallization. And I remember these days, Leslie, when he was involved in that, he was so excited, because now I can do something that my father taught me about. And he entered in the process of malaria, and he basically performed very important experiments. All this was done after retirement. So what I thought about it, Leslie was interviewed in an African journal. There is an African journal of the Jewish community actually interviewing people that met Aliyah to Israel. And I went across this manuscript, Leslie, and I found something that touched me, and I'm sure that it will touch you as well. And this was one problem. Leslie's mother, who died young, only in her 40s, was today looking down from the celestial perch. She would be amazed and proud that from the simplest pattern of the daily dressing lay the complex mysteries that would inspire a brilliant son to pursue a journey of scientific exploration culminating in the Israeli Prize. In other words, I think, and I would like to add now, Leslie, to that your father, who might also be watching to you, he would have the similar feelings because of what you've done in general, but also in particular what you have done about malaria, and you feel that it also inspired you to go into this project of malaria on the problem. So this, what I think that I've not told in my previous meetings, Leslie, so I hope that you would enjoy that. Now, first of all, I would like now to thank Ruchama. In Hebrew, we have a saying, מאחורי כל גבר מצליח עומדת אישה תומכת. And I think that you have also a very important part in the success of your husband. I would like really to congratulate you, Leslie. I know that you will continue with your science. I see you today when you come in my office at 4 o'clock, you have to run to the other building to meet Rita because she's performing some kind of study, and I would like to see how this project will project, and we're going to publish this in Nature or in Science. And I would like to really to wish you many additional years of health. I think this is the most important part, health, and to continue with your spirit to do nice, beautiful science. And in particular, Leslie, I would like you to continue to enjoy your hobby. This is the promenade along the hellies of the Weizmann Institute, and to listen to the beautiful music of the birds every morning. תודה רבה.